This video is going to be on the Pythagorean Theorem. It's going to be one of your most basic geometry theorems that you memorize, especially when you get into trig. Trigonometry makes a lot of use out of the Pythagorean Theorem. So this is one of the more important ones to see and recognize. So I'll just get right into one of the proofs for it. I may make a video on another proof for it. Just depends on if it's useful for any other videos that I'm going to be making. But the first thing to see is this is going to be a square, and I'm going to let the sides on this square be a plus b and a plus b. So I can find the area of the entire square by summing up the area of the parts. In other words, this square, and those two rectangles. So I know each of those areas, that's going to be a squared. That's a times b. Since we have one of the sides is a and one of the sides is b, and this is also a times b, and that's b squared. So I know the sum of the parts is a squared plus ab plus ab plus b squared, or I could just say 2ab here. So I guess I could say capital A is the area. So capital A is the area of that square. And I'll just denote it like that. Okay, so what if I rearrange the square a little bit? And I can do that as long as the two sides are a plus b. So I'm going to let this one be A and that one be B, and then I'll let B be right here and A right there. And sorry if the sizes are a little off, but okay, so now I'm going to construct these right triangles here. And this is also going to be B and that's going to be A. And we're just going to construct these right triangles. And this is just a quick proof. If you wanted a full proof, you'd have to prove, for instance, that this is a square on the inside of this larger square. That can be proved by knowing that we have 180 degrees, that the three angles of a right triangle add up to be, or any triangle add up to be 180 degrees. And then we know that since this is a right triangle, these two have to be 90 degrees. So I know if A plus B is 90 degrees and a line is also 180 degrees, then this would be a right angle there. And you can prove that in that way you can prove that this is a square on the inside. That's important for like a more rigorous proof of the Pythagorean theorem. But I'm just kind of showing it really quickly. I'm not going to go through a geometric proof of all the steps. So we know that the areas here are equal. So I know that this is going to be A, the area. But I can sum it up in a different way. The sum of the parts is the whole. So in other words, I can say if I know the area for each one of these triangles, which I do, it's 1/2 A times B, then 1/2 AB. I'll say area is equal to. Also, one quick note. This is a C. So that's going to be the C part in the Pythagorean theorem. This is going to be the hypotenuse there. We're going to let that be C. So I know 4 times 1/2 AB. So since I have 4 triangles and I know the area of each of them is 1/2 AB, I know that the area of this, and this is 4 times that, and then plus C squared as well. So I know I can represent A as this, and I can represent A as this. So now I have a relation A is related to A and B in this way, and A is related to A, B, and C in this way. So I'll just put them together and I can solve for C. And then I'll have C in terms of A and B, which is exactly what we want for the Pythagorean theorem. So really quickly, I guess I can do that right here. So A squared plus 2AB plus b squared is equal to 4 times 1/2 is 2, so 2ab plus c squared. All right. And so from here, I can subtract out 2ab on each side, and I have a squared plus b squared is equal to c squared, which was the result we're looking for the Pythagorean theorem. All right, so this is just a quick proof. If you wanted a full proof, like I was saying, you'd have to prove that this is a right triangle. That this is a square, so we'd have to prove that each of these are 90 degree, the angles are each 90 degrees, and then you'd have to prove that each one of these are congruent triangles as well. But once you prove that, it's not too hard to see that the areas would be equal and that they're the same square. And there might be more detail in that proof, I'm not sure. But this is just a quick overview.